Hey folks, this is Mr. Woodward giving you an introduction to energy. Let's just jump right in. So first of all, what is energy? Um, we talk about it, commonly in everyday speech, and it's oftentimes has vague meanings. But in physics, we really try to pinpoint the idea that energy is the ability to do work, and specifically the work of moving something. So it takes energy to, move your desk across your room. It takes energy to send a sound wave from a speaker to somebody's listening ears. And that work would be the work of moving air molecules, vibrating them in place across a wave. And then it would take work to even heat up your food. Every time you put something on the stove, the thing that's moving in that case would be, applying heat to a pot of water eventually brings the water to boil because those water molecules are vibrating at faster and faster rates. So that the work of heating is literally moving those water molecules faster and faster and faster. So I've mentioned a few examples of doing work requiring different kinds of energy, but there's a lot of different kinds of energy out there. And I'll just run through a few of them. Electrical energy is stored in electric fields, and it's released as electrons move, right? There's that idea of the ability to move something. Sound energy is essentially vibrating air particles in the form of a sound wave. Light or solar energy is vibrating photons. Nuclear energy comes from fission and fusion reactions, so you can think of a nuclear reactor, or you can think of the energy that's powering the sun. Chemical energy, like what you get from eating food, or like the energy that is consumed and released in a fire, is essentially stored in chemical bonds. Thermal energy, like heat and temperature, again, what's moving there is these vibrating molecules, which is really what temperature is a measure of. And then we will focus in this lecture on mechanical energy, of which there are two kinds, potential and kinetic. So potential energy is based on an object's position, like where it is, and kinetic energy is based on an object's motion, specifically how fast it's moving. So let's focus there on mechanical energy, right? It comes from an object's position, that's the potential, or its motion, that's the kinetic. So within potential energy, I'm now going to detail this a little bit more and even give you some equations. This first kind of potential energy is called gravitational potential energy, and it's energy that's stored in a gravitational field. Okay? How is it stored in a gravitational field? Well, think about climbing a ladder. When you climb a ladder, you increase your potential energy because you increase your height above the ground. And what you're doing when you're increasing your height above the ground is that you're actually moving against a gravitational field. So you're doing work to move yourself higher and higher within that field, and therefore as you move higher in the field, you're gaining this kind of energy within the field called gravitational potential energy. And then you've got the equation here that it's equal to mass times gravity times height. So the more massive you are, the more gravitational potential energy you have. G for Earth is 9.8, but if you went to a different planet, G might be larger or smaller, so that would affect the amount of gravitational potential energy available. And then H is your height above the ground. So the higher that you climb, the more gravitational potential energy you have at that height. But there's another kind of potential energy, which is energy that's stored in a spring or a rubber band. It's called elastic potential energy. Okay, and so think about the energy that's actually available when you stretch a spring. It wants to recoil back to its original state, or if you compress a spring, it wants to recoil back to its original state. And so the amount of energy available is related to two things. You can see in the equation 1/2 k delta x squared. K is called the spring constant. That's a measure of how much how difficult it is to stretch or compress the spring. It's essentially how stiff the spring is. And then delta x is how much you are changing the length of the spring, right? So the more that you stretch or compress the spring, the more energy that you're going to be storing in that spring. Okay, so here it is, two kinds of potential energy: gravitational potential energy or elastic potential energy. But then remember that there's also energy that's available in the way that an object is moving. And that brings us to our second main type of mechanical energy called kinetic energy. Kinetic energy is 1/2 mv squared. And so it's related to mass and velocity. So the faster that you run, the more kinetic energy you have. And specifically, if you double your speed, you can see that it's proportional to velocity squared. If you were to double your speed, you would actually have 4 times as much kinetic energy. Now, there's a great online resource from PhET called the Energy Skatepark. It's free at their website, and it allows you to explore these different types of energies through a girl who's riding a skateboard on a half pipe. And so in this picture, you can see that there's a graph on the left side that's measuring her different energies. She's got values for kinetic, potential, and thermal. And then there's a graph for her total amount of energy, which is, adding all those energies together. And as she moves up and down this skate park, it will show you how her different types of energies are changing with her motion and with her position on that skate park. So that would be a great place to go after this to further explore different kinds of energy.